A warm welcome to all of you. Let's back to our sessions. It's time to start my session. Thank you. So this session is about essentials of NLP. A natural language processing essentials. I'm going to take you from theory to practice. By the end of this session, you are going to learn about defining exactly what is natural language processing, different applications of natural language processing, the core concept of natural language processing, how these applications will be implemented, the actual process behind this, all the tasks of the natural language processing. This is called pipelining process, and hardcore concept of this pipelining process is text processing, which is major important task of this natural language processing. Along with that, what are the different NLP libraries or the tools that we can use for applying and implementing all these NLP tasks. And we are going to wind up with this session with a case study of sentiment analysis. These are the objectives of this session. Before going to define what exactly is the natural language processing, let's talk about how human will interact with other. If you want to convey your intention to other, you will speak to them or you will text a message to them. This is the way. It's a way of communication a human being will do with other, either by speaking to them or else sending a message. This is what called natural language. So what exactly the natural language? First let us see. It's a means of communication to another human being or between two human beings, either by the way of speech or text. If we observe carefully across the globe, you can see there are many languages are existing across the world, and daily, virtually, a lot of messages, billions of messages or the conversations are sharing across the world virtually. All these conversations, messages, charts, documents, and whatever it is, all these things is called a huge data which is more valuable. But the point is, this data is useless to your computer. Am I correct? Yes, because all this data is text, textual information, natural languages, textual information. Machine cannot understand these natural languages like English, Spanish, Japanese or some other. It understands only the binary. So in such case, this data is useless to the machine. Here where the NLP, the concept of NLP come into the picture. So what exactly the NLP is? Nothing but it's a way of making a machine to read, understand, and making a sensible and valuable information, whatever the human beings are communicating together. Making it is sensible data. Actually, it is a task. NLP is the task of processing written forms of languages which makes understand by the machines. Written forms of different communication languages which makes understand by the machine for performing any task. This is what exactly the NLP. So NLP is, in order to define it technically, it is an integration of the computer science, AI, and human languages all together. Understood? Right. This is what exactly the definition of NLP. Before going to deeper into this NLP, let's have a look on the use cases, applications of NLP. Already we had a few one or two applications that we had discussed in the prior session of recurrent neural networks. 2-3 slides will be repeated, but don't worry about this. I'll take you in a proper way. Let's have a look on those use cases. This is a very beautiful first use case. Sorry. The first use case of this NLP is Google Translation. If you have seen that Google Translator, you can see a beautiful way of translation from English to Telugu. That was there on this slide. I had shown you only one particular language translation. There are hundreds of languages are there that you can do this. This Google Translator is text. It's in a text which is in English language has been translated into a text in Telugu language. Text to text generation. So the machine has to understand the sequence of words in English and has to process that and has to translate into a sequence of words in another language. I defined this NLP is the task of processing written forms of natural languages. Thus, this Google Translator, nothing but the concept behind it is language translation is one beautiful use case of this NLP. Let's see another one, the second one, auto completion that we have seen earlier. Here in this case, I am trying to phrase, here in this, I am trying to phrase an email addressing our HR department Smriti to schedule an interview on a particular day. I just typed it here in reference to the above. When I am typing the keyword ABOV, I can't be able to show it here, but it has predicted and recommended the word E, which is the next character in the word above, along with that the next word in the sequence, mail, email. Okay? So what it is, it predicted the next character in the word and the next word in the sequence of words. Thus, it completed the complete sentence. Thus, autocomplete is also a beautiful application of NLP. Spelling and grammar checker. I am typing some documentation and it suggested me, I used the word less, but it suggested me the word fear. Along with the descriptions, less is for, fear is for numbers and less is for intangibles. How beautifully it is suggesting me. And you can look at here, I am looking for my next career opportunity. This is the sentence I am trying to face. Here the context is opportunities is related to some occupation, but I mistyped it as career. It suggested me, no, you are going wrong. You are supposed to use the word career because it is related to the context of occupation. If you are in the context of something which is carrying something, then you could go for career. Behind this is again predicting. It is capturing the context of the sentence in the sequence of words and predicting the next possible word and checking whether it is meeting the context of the sentence or not. If it is, because it is not meeting the context, it is recommended this is wrong, spelling wrong. Spell checker is another application and another is spam mail. If you open your Gmail account, obviously you could see this location spam. What is this spam folder? In my spam folder, I had around 228 emails which have been identified as the spam emails. When a mail is received to your, reached to your inbox, by identifying and capturing certain threaded words like amazing, you are lucky, a bumper offer, like words. Capturing and recognizing and identifying the words, such words, based on some rule based algorithm, the machine will categorize those mails are the spam mails, labeled as the spam mails, and throw it into the another folder. It's a sort of classification. So it is also one application of this NLP. And customer service chatbot, you know very well. We are using our Surabhi in KMIT website also. What is the job of Surabhi? When you post a text or the query, that is called the, you are typing in the form of the sentences, right? It is identifying and capturing the most important words about what you are asking the posted the query. And for that word, relevant information will be grabbed from the database and will be replied as a response to that query. This is what the job of the Surabhi is doing. The same thing you can see with the different service chatbots in many of the sites. I presented one bank service chatbot in front of you. So chatbot is one more application of NLP. Search engine. Do the search engine is also an application of NLP? Yes. Just before Priyanka ma'am told about the search engine. When you are typing the text itself, it is auto-completing and recommending relevant information or the questions to whatever you are posting, along with the supporting links or analysis to that query or the text. These are very well known, all of you are using, all are the voice based. Siri, Alexa and Google Assistants. And this is another one. Bloomberg, how many of you know about this one? Can you raise up anybody? Bloomberg is a beautiful AI tool, NLP tool, which will be used for generating articles, news articles. It will automatically generate the news articles. If you see the slide, this is called the Bloomberg terminal. Whatever the yellow colored links that you could see here, orange colored, all these are the news articles generated by the Bloomberg at the terminal, and these are all are automated news articles. No need of physical editors to generate a news article. It will automatically will generate the articles. So this is also, here is also behind concept is text generation based on the context. So thus it is another application of NLP. Okay. We have seen few applications of NLP. How to implement all these things? We need to go into the implementation process. The most beautiful and most important thing is implementing all these concepts is called NLP follows a pipeline strategy. We know the meaning of the pipeline. What is the pipeline? It's general sequence of stages, one after other sequence is to be followed. Why we are calling it as a pipeline? The output of one stage will be the input for the next stage. So simple to remember. All those NLP tasks we will implement by following the strategy called pipeline, NLP pipeline. Let's have a look on this NLP pipeline. These are all the different stages in the NLP pipeline process. The first stages we have, most of the stages we have already seen with the MLP applications, not the MLP, sorry, ML, machine learning, deep learning applications. It starts with the data acquisition, collecting the data from the different sources, and then we'll go to the cleaning of the data, the primary stage of cleaning of the data during the collection process of the data. Then the next thing is text processing. This is very, very important. Of course, we already done it even in the machine learning algorithms, right? Why we need to process? That is what you called EDA, exploratory data analysis. Because we wanted to make the data whatever in our hand suitable for the machine learning algorithm, some sort of processing. But here it is very crucial thing in NLP, that is we are calling it as the text processing. Once the text processing, we are going to see that once the text processing is done, now the data in a proper format is ready for my model. But I am not going to use the entire data for my model and performing particular task. I need only few things to be used in a proper way. That is what the stage is called feature extraction. From the data, what are the important features and how these are to be presented to the model. We can't directly present the entire data, whether it is the pre-processed data, directly to the model. Features to be extracted, right? That feature extraction is the next stage in the NLP pipeline process. Then the rest of the things are as usual with ML algorithms. Then I can go to the model building by choosing the proper model. Once the model is built, I will train against the training data set and will perform the study, its behavior and its efficiency and accuracy on against the test data set. If my model performs well, okay, I will go for deploying at the client side. Otherwise, I would go for again changing the whatever the requirements processing else to be done, will repeat the cyclic process. Once the deployment is done at the client side, then the last stage is monitoring and keep updating the model and along with the continuous data. So, overall this is the pipeline process. Now, the focus of this NLP is, the main thing is text processing. This is the most beautiful and very crucial and important thing in the NLP. Let us move on to the concept of text processing. I will take you to the concept of text processing. This text processing involves different types of processing. No need to follow the sequence. It is only the different procedures. According to your data, according to your requirement, whatever is required processing, that we can do. Okay. Let us have a look on what are the different text processing methodologies that we are using in an NLP application. The original raw data which has been collected will go to the segmentation, is the first text processing methodology. Then tokenization, stemming and lemmatization, stop word removals. Any stop words or punctuations are there in my text because I am handling the natural languages, spoken languages. Certain words which are not having the meaning, do not carry those words while extracting the features. That words I am going to remove. So, stop word removals and punctuation marks removal. And another concept is named entity recognition. I am going one by one in detail. Parts of speech tagging. Here only I presented few. You have some more also, like parsing, identifying the objects and dependencies. These are all the different text processing methods available in NLP. Let us go into the one by one deeper, whatever is required. Segmentation. Segmentation is a so simple thing. The concept of segmentation is, you can see this example, you can better understand this one. Here is a text in front of you. I kept it in the single quotes, it is a text which is consisting, you can call it as a text or a document or the paragraph. It consisting of 3 sentences, natural language processing, this is my second sentence, this is the last one. In my text there are 3 sentences. Segmentation is the process which will broken the text or the paragraph into sentences. We know the delimiter of the sentence, that is period symbol. It split the text into sentences, simple thing. First of all, one entire documentation, whether it is a PDF or something is given to you. First of all, it is to be divided into sentences. Can you guess what is the next stage? Obviously, the entire paragraph is first divided into sentences, then sentence is to be divided into words. That we are calling it as the term called tokens. So, this process is called tokenization. Tokenization is the process of splitting the sentence or the paragraph or the text into words. You can see here how it is tokenized. Natural language processing is the text. Once you did the tokenization, you will get a list of tokens. Tokens are nothing but the words, right? Another text processing technique is removing punctuation marks. Punctuation marks don't carry the meaning. When you are processing and feeding the data to the models, when you are understanding, capturing the context and emotion of the sentence in a particular natural language, these are required. If you are putting exclamatory marks, means you are feeling highly exciting. That is the excitement or the feeling that I am getting while understanding this natural language, but that is not required for the machine. So, those such characters should be removed while processing and extracting the features. So, punctuation mark removal is another thing. You can look at the sentence which is given in front of you. Here in this sentence you can see a different punctuation marks which were stricken with a red color. Those are not carrying any meaning for my sentence. So, I am going to remove this. So, punctuation marks removals, if you remove, what I am going to get, this is the sentence. Does the meaning of the sentence is changing? No. Then why I need to carry? Unnecessarily more parameters are required for my model to handle those punctuation marks. I don't want that. So, I am going to remove. So, what are the punctuation marks? These are the punctuation, list of punctuation marks that you can see from the English language. Similarly, you can get the punctuation marks that we are using in different languages. First of all, we have to know this. Those punctuation marks are to be removed while processing the text of that particular language. Stop words. Stop words is also similar case like the punctuation marks which are not required. For sentence phrasing, these are required, but while you are extracting the features, these are not required. Those are also going to be avoided by removing. You can see here, an example is there in front of you. A sample text with stop words is there, Greeks for geeks, which is defined as with a hyphen, a computer science portal for geeks. This is the sentence or the text. Once you have a look at without the text without the stop words, geeks for geeks, computer science, portal, geeks. These list of words, doesn't it giving the meaning of that particular definition? I am getting right. So, what are the words removed? This hyphen has been removed, a has been removed, for has been removed. Those are the words which are useful for phrasing the English sentence, but are not useful for extracting the features while feeding the data to the model. Such a stop word should be removed. English sentence has such a stop words like a, for, is, like those words. Similarly, you can customize. Somewhere when you are working with certain type of task like the translation, obviously you need of certain words which are required for capturing the context of the sentence. You can't avoid all these stop words whatever this English sentence is, English is maintaining. So, customization of the stop word should be done while you are processing your text against the stop words removal process. Right? Lower casing. Do I need to do this? Is the lower casing is also a processing, text processing technique? Is that important? Can anyone? Is that important? Is lower casing is mandatory for as a text processing technique? Huh?
All what you see meaning.
Same meaning. Whether it is the capital letter or initial capital are totally lowercase, the meaning is same. So, when I am extracting the features, before going to extract the features, I am going to create the vocabulary. When creating the vocabulary, what is the need of keeping the same word repeatedly, whatever the case is? Am I clear? What is the need? If I keep memory space, additional memory space is required. What is the need? If it is a capital and initial capital and lower, because the terminology this is different, obviously I need to keep more parameters to process and understand each and every repetitive tasks. No need of for the machine, right? So, lower casing is very, very important. Do not underestimating is the lower casing is that important pre-process. No, it is very, very important because it reduces the vocabulary size. Stemming. Stemming is the concept of finding the stem word or the root word. Have a look on this example which is given in front of you. Consult is a word, consultant is a word, consulting, consultative, consultants. According to your sentence, all these things will carry different, but the root word is consult only. That is sufficient when I am extracting the feature. So, stemming is the process of finding the root word while creating the vocabulary. So, it is also an important. So, what is the meaning of stemming? It is doing, it removes the last few characters of the word, sometimes often leading to the incorrect meaning or spelling. So, you have the choice to use whether the stemming is to be done or not in your data set according to the task that you are implementing. Another one is lemmatization. There is a small differentiation between stemming and lemmatization that you need to understand. Lemmatization is also the concept of finding the converting into the root word, but here it will consider the context, in which context you are converting. I will show you with an example. So, which context means whether it is the verb or the noun, in which context you wanted to change it, that is to be specified. This is what called the concept of POS tagging, parts of speech tagging. So, in order to do the lemmatization, we need the POS taggings. See this example, you can better understand. Run, running, ran. These words will be stemmed, converted into its lemmatized root word, that is called run. It is capturing the meaning, one word is sufficient, right. But if you see this example, is, was, am, their root word is, even in this case, their root word is same thing, but in the context of noun. If these were used in the context of noun, their root words also will be the same, but the same words were used in the context of verb, these will be converted into be. Thus, I am reducing my vocabulary also. Okay? This is the overview of stemming and lemmatization. The next is what I said, context, the part of speech tagging. When you are phrasing the sentences and translating or processing the sentences, what are the parts of the speech that is also important? Whether it is noun, verb, pronouns, objective, determinant, all these things to be identified. See this example. I enjoy solving data problems, and this I is a pronoun and these enjoy and solving are the verbs, data and problems are nouns. Identifying each word in the sentence, what type of parts of speech it belongs to. This is also an application. Then these are all the different parts of speech that are available. Named entity recognition, another one. Another pre-processing technique is named entity recognition. What is this is, let me show you an example. Sundar Pichai, the CEO of Google Inc. is walking in the streets of California. In this sentence, I wanted to capture, you can capture the Sundar Pichai is a person, Google Inc. is an organization, and California is a location. The entities pre-processing techniques in an overview, how these were implemented by using one of the NLP tools or the libraries. Before going to that, let me show you what are the different tools that we can use for performing these NLP tasks. These are all the different libraries that we can use for NLP tasks. NLTK, LNLLP, this was the old one. Stanford and LNLLP are the old ones. We were using in the early days of this NLP. The popular is NLTK, Spacey, Hugging Face. You know very well, you heard about all these things very well. And simultaneously, we can use this sklearn, text block and Gensim. Gensim is the library that we can use for the embedding. For different purposes of this text processing, we will use more efficient libraries we can use. Some libraries will give an efficient results for particular task of pre-processing are the NLP applications. Anyhow, these are all the different libraries, not visible, okay. These are all the different libraries that we can use for NLP tasks. Now, I am going to show you the text processing methods and different strategies that we had discussed till now with one of the NLP library that is called NLTK. I am going to give an overview. Escape. Text box. Zoom. More. So, whatever the text processing that we discussed till now, I am going to show you how it will work. So, first of all, we need to import NLTK library that we can do with the import. Once the NLTK is imported, then you can look at different functions that are available in the NLTK library. Come down. You can have a look on all the different functions that are available here. You can see the Stanford, stemming that you can use for tags, text, tokenize. Can you observe here? That is the function that we are going to use for tokenizing your text. Okay. Thus, we can see all the different functions which are available when you imported the NLTK library. Let us go to the next cell, sir. Yeah. Once imported, then we need to import the required modules which will perform this. Yeah. From NLTK.tokenize, I told you, tokenize is the function from the NLTK which will be used for tokenization process. So, I imported the library NLTK.tokenize import word underscore tokenize. This is the function which we will be used for word tokenization. Sent tokenize is for sentence tokenization. Come down. So, this is the sample text what I shown in the slide. Same thing was taken. This is my first sentence. This is my second and the last one. A text has been created or the document has been created and stored into the variable. Then I am going to apply the sentence tokenization by passing the text one as a parameter to that. Is it clear? I already imported the required library called sent tokenizer, but I didn't get, I got the lookup error. Can you come down, sir? Can you highlight this one? No, little bit. Yes, it suggested you. Resource punkt not found. We need of the punkt library which is required to do the tokenization processes, and it recommended you to download the punkt library using the command nltk.download. Download is the method which will be used along with the NLTK library module to download whatever the packages that are required relevant to the processing task. It recommended me, in order to use the sentence tokenization, it recommended me to use the punkt. That's what I did next, and run the code cell, come down. So I downloaded this punkt. If you didn't pass any particular parameter to the download method, it will download all the packages. Come down. Then ran the same code cell again, sent tokenization. Now you can see this. What is the output? A list of sentences. Okay? I did well the sentence tokenization. Come down. So I got the length of this result also. There are 3 sentences I got as a result of sent tokenization method. Come down. The next is word tokenization. We already imported the required library word underscore tokenize. I am going to call this method by passing the same text which I had created. So it created the word tokens. The output you can see a list of words, nothing but list of tokens. Can you observe this period symbol is also there, dot symbol, which is the end of the symbol. This also been identified as a token by the word tokenize of NLTK. Come down. There are 17 word tokens are there in my text. Come down, sir. We can do this tokenization in different way also called, this is called tree bank word tokenizer, another method. Earlier I did with NLTK tokenize word tokenizer. This is NLTK dot tokenize import tree bank word tokenizer also can be used for different methods also there. I am just presenting 1 or 2 methods as a sample. If I did so, can you observe? Have a look on this word tokens which have been generated by the tree tokenizer. Just go down, sir. Yes. Can you see this period symbol? Okay. So that's the difference. Tree bank word tokenizer is not considering that period as the token. It considers it as the stop word. Stop word are punctuation marks. Right. So with this I got the length of the tokens is 15 only, because 2 times I got this period symbol in the earlier case. So that's I got this 17 tokens, now it is 15 tokens only. Come down. This word tokenization you can do using the regular expressions as well. Hope you know very well about this one. Regular expression module is imported, import RE library, using the find all method of all the words followed by any characters. This will give you the all the words. With this I got the count is now 14. You found out what are the missing things are there. With each library the effect will be different. So you need to capture, are you missing any data when you are tokenizing the sentences? That is to be captured and choose the proper way of tokenization. Come down. Yeah, the most important is contractions. Handling contractions is very important when you are tokenize the sentences. Have a look on this one. When I am applying the word tokenize on the sentence, I don't like it. How it gave this tokens? Do not. It's somewhat meaningful, right? Can you come down, sir? Can you look at here? Can't is a contraction. How it is tokenizing? CA is one token. NT is another token. Is it meaningful? So that you have to catch. Come down. Different examples. Come down. Regular expressions gave me very good results. Come down, sir. This is also word punctuation also I use. But I got a very good effective results with the regular expressions only. You can see that. From NLTK.tokenize import reg expression tokenizer. I imported reg expression tokenizer for splitting or word tokenizing the contractions. I got a very good results, effective results with the regular expression tokenizer to tokenize the sentences which containing the contractions. I got it very good. Can't is a contraction. Effectively, I got this tokens. Enough. So, lower casing is so simple thing. Text dot lower is the method you are supposed to call to convert whatever the text into lower casing. We had discussed the need of the lower casing because it is going to reduce the size of the vocabulary. So, you can observe here how this T is converted into lower case. So, simple thing, you already done it well, no need to explain much. Come down. Stop word filtering. Now, this is a lesson. We have to remove the stop words from our text. First of all, find out what are the stop words. That thing you can do by downloading stop words from the NLTK module. That you could do with NLTK, the download of stop words will download all the stop words. Once this is downloaded, stop words which have been downloaded, that stop words are going to be displayed here. So in order to display, you are supposed to call it stop words that already you had input. The stop words dot words of English language is to be specified. In which language stop words you wanted to see? I wanted to see the stop words which are provided in the English language. So that English was passed as an input to the stop words dot words. Then these are the list of stop words in English. I, me, my, ours, us. All these are the list of words. Now process your text against this list of stop words to remove the stop words from your text. It's a simple Python logic. Search for each word in your text, whether it is there in the stop word list or not. If it is there, remove it from here, from your documentation or the text. It's a simple Python logic. Come down. This is the logic. Each word in the word list, if the word is not in stop words, then it will be appended. Similarly, punctuation marks is also supposed to be done in the same way. But in order to do the punctuations, you are supposed to call the string method, string operations to be called up. Little bit scroll up, sir. Scroll up. Yes. String dot punctuation. This is how you will get the punctuation marks. Come on. Down. You can see the original text and the text after removing the punctuations and the stop words. You can see, is my is there in the processed list? It's not there because my was identified as stop word in English. That was removed after this simple Python code. On, a are also not there. You can see here. Those stop words once have been identified, those will be removed in your text, so that you will get the processed text after removal of stop words and the punctuation marks. Now creating the vocabulary. What is the meaning of vocabulary? You have done the tokenization, you deleted the stop words and punctuation marks, all are there with you. What else is left over? Unique words. One time only sufficient. We already converted into the lower cases. Right? One time only. So, from the list of tokens which have been already processed, you need to create a set. By passing that list to a set, it will create a list of unique words. That is what called vocabulary. So, once the processing is done, we have to create the vocabulary. From the corpus, we came to the stage of vocabulary. Corpus is your entire text data as it is. Once the processing step by step, we will come into the vocabulary, right, with all the pre-processings. So, we can do this vocabulary creation along with the count also. It is a simple Python logic, checking whether the word is existing in the list or not. Come down, sir. Yes, this is the logic, simple logic. You are creating a dictionary. For each word in the list, you are checking, because it is a dictionary. If it is already there in the dictionary, then one will be added. If it does not exist, first time it will be counted. counting the number of words in a dictionary or the list and creating an output dictionary is a Python simple logic for creating a vocabulary with word count. Come down. Yeah, this is a frequency distribution. How many times that word has occurred? What is the need of this one? I will tell you in the next case study. Right? How many times that word has occurred? This is also a simple Python logic. Come down, sir. Come down. Yes. You are creating an empty dictionary. For each word in the list of words, we are getting a particular word from the vocabulary, I mean to say dictionary. Counts A is my dictionary, empty dictionary which is initially. I am seeking for the word or the key value in the dictionary. If it is found, 1 will be added. If it is not found, first time it will be counted. Thus, a number of times that word has occurred will be calculated. So, finally, I would come up with this output. This is the key which occurred for 2 times. Is for 2 times, likewise. It is a dictionary. My output is a dictionary. So, a vocabulary along with the frequency count was calculated. Right? Come down, sir. Yeah. Stemming and lemmatization, we already shown you. Let us see how to implement this one. Examples also given to you. Again, it is given in the text format in your code cell. Down. Directly go to the code cell. Yes, this is what. How to do the stemming process? From nltk.stem, we need to import the porter stemmer. Different stemmers are also there. What are the different stemmer? What is its behavior, architecture of stemming process that you have to study. What I am using here is the porter stemmer. I am taking a example sample word beautifully. I am going to see how this word or the token is going to be stemmed against the porter stemmer. Right? I am creating an instance of the porter stemmer class called stemmer and calling the stem method with respect to this instance and passing my text beautifully to this one, and the result is I am going to getting it is beauty. The root word of the beautiful is beauty. That is sufficient for getting and capturing the meaning while extracting the feature. This is how the stemming will be done. Come down. Can you guess? Yes, here is an example. Playing, plays, played. The root word is play. That is what I got as an output. Play, play, play for all the 3 words in the list. Okay. I tried with another example, beautiful, sunflower, sunny, Friday, and the second set is also, could you please show the second set? Learning, learned, learned, happy, happiest, happiness. This was the text passed to the stemmer. Now you can see the output of my stemming result. Learn, learn. For learning, learn, all these things I got this learn only. For learned I got as it is learned. Okay. Happy. Can you see how this happy was stemmed? H-A-P-P-I. That's what I said. Sometimes meaningless. As a natural language understander, as a human being, you feel this H-A-P-P-I is the meaningless word. So, lemmatization will give such a results also, but you need to take care. If you want, you can do, otherwise don't wait. Then come to the lemmatization process. Come down. So, what is the difference between stemming and lemmatization? I said both are the concept of converting into the root word, but the lemmatization will consider the context, whether it is the noun or verb, on which context you wanted to get the root word. Now, we are going to see this. NLT, yeah. First line. NLTK.stem import WordNet lemmatizer. You have to import WordNet lemmatizer and create an instance of the WordNet lemmatizer and pass your word as an input to that. LM. Come down. This is the word list I am changing. sorry, this is the word list I am taking. Changing, dancing, is, was, am. We have seen this stemming, how this is doing the lemmatization on the slide itself. I am trying to show you the same example. When you are processing this LM dot lemmatize, LM is the instance of the wordnet lemmatizer which we have created. For that we are passing each word in the list, so that I am going to get the lemmatized word. Can you see how these are getting? Changing, you got the changing as it is. Did you observe any change? No change during this lemmatization process. Okay, dancing as it is as it is, was as it is, but you can observe was converted into wa. Meaningless. Okay, fine. Come down. So, why it hasn't shown anything is, no differentiation is, because this was processed against, this list of words were processed against the context of noun. But I want this lemmatization is to be done against the context of verb. That is what I am going to mention. This context can be specified by the variable POS tagging, the variable called POS. POS is not the position in this parts of speech. So, parts of speech that I specified is the N stands for noun. Because I am passing this N, there is no change observed. You can see again, come down sir, output. So, lemmatized words, no change observed. But I did the same thing by changing the context to verb, next cell. Can you see this? Show this one, POS variable here. LM dot lemmatized word, can see. I changed the POS tagging is verb. The meaning is context is I am changing it to the verb. So, now I got the result, you can see here. Changing is converted into the root word change. Is it meaningful and sensible? I got succeeded. Dance, you can see here. How this is, am, was converted? Be. It's meaningful. Okay? So, while doing the lemmatization, you need to specify the context by the POS tag variable. Done with this lemmatization and stemming process, come down sir. Come down. Another examples, these are another more examples only. Directly go to the POS tagging. Different example. How this stripes was converted, POS tagging. Come down. Yes. These are the list of words I wanted to generate the POS taggings. It's a recommendation made to me to import that tagger. No need, come down. So, we supposed to download average this particular package which has been supported, suggested, Perceptron tagger. While you wanted to use the POS tagging, it is recommended me to download this particular package. That is what I did. Once I downloaded, I successfully able to do the generate the POS tags. Come down. Yes, this is what the text. In order to get the tagged words, POS tagged words, the code supposed to be written is nltk.pos tag. This method is to be called up by passing the list of words. It will generate the POS taggings likewise. It creates a list, output is a list of tuples. Each tuple is token along with the POS tagging. He, PRP, proper noun. These are the different notations that you can see from the Stanford or Tree Bank library that you can see here when you are in detail studying. NN is a noun, verb, DT is a determinant, likewise. Noun, proper noun, NNP is the proper noun, noun in present tense, likewise. This is how you can generate the POS taggings. And the last I am going to show in the pre-processing is named entity recognition. Do you know what is the use of this named entity recognition? where are the applications, main applications of name entity recognition? When you are processing the medical data and the entire text of patient information on all the details, whether the doctor prescription and all these things, you wanted to identify the what are the diseases. The terminology is not well known to everybody. It is not the common terminology, medical terminology is different. You wanted to capture that medical terminology, names of the drugs, names of the diseases, symptoms. In such cases, this is the most beautiful application, named entity recognition. Come down, sir. So, in order to that, I am going to show you this named entity recognition is, I got a very beautiful results with the Spacy library. Till now, I had shown the pre-processing all these things with NLTK. But for named entity recognition, I am using this Spacy because we can show a very beautiful effective results we can show it. We can do it along with this NLTK also, but it's not, output is not that effective. That's it. So, in order to do so, you just have to import Spacy library, and the model is also supposed to be imported. There are different models are also there. You can see here English Core Web SM. SM is the small model. So, like a medium large models are also there. I just downloaded the small model, small English model using the Spacy library. Then pipe underscore names will give all the pipeline stages. We have seen all the pipeline steps. What we have seen? Stemming, lemmatization, POS tagging, named entity recognition, all these are the pipeline steps, right? So, that you can say here lemmatization NER. NER is supposed to be used if I wanted to do the named entity recognition. Come down. This is what I did. I took the same example, Sundar Pichai, the CEO of, same example is taken and created the document back. By passing that text to the NLP, you will create the text or the document using the Spacy library. Then for ENT, for each entity in the doc.it, this is my document. Within the document, ENTS is the annotations. There are different annotations are there. ENTS is one annotations which will extract each entities in the text. My document is this so and so, Sundar Pichai, the CEO of, like this. So, for each ENT in entities, it is displaying entity.text, that is the Sundar Pichai, Google Inc. California, and the corresponding label. Can you see what is the labels you got? Person, it's been identified as person. Google Inc. is organization, California is geophysical entity. Okay. This is the use of Spacy library to identify the named entity. This you can visualize also in a beautiful way. Come down. Explanation also you can take by using another annotation, ENT, yes, Spacy.explain, little bit more. Right. Yeah, Spacy.explain of entity label. That will give you the explanation. It has shown ORG person. What is the meaning of this ORG person? It's been explained here. Person, people including fictional. ORG, companies, agencies, institutions, likewise the explanation also you can get it. These are all the different annotations. More annotations are also there, you can study well. Come now. Visualization entities also you can do this. For this you are supposed to download, import Displacy, the library Displacy. If you once downloaded this library by rendering the document using the style entities and using making the Jupyter notebook is able to capture, then you will visualize your entities, show the outputs. In this way, you wanted to identify and highlight the drugs in the medical data. Okay, fine. Right. These are all the different pre-processing techniques. Done with this. Let's back to theory. Okay, I had shown you the basic pre-processing techniques, the text processing techniques that are required for the NLP. Hope I am clear about this one. Any doubts in this? I'll go to the next thing, case study. Next. It's sentiment analysis. Now it is interesting, I am going to show illustrative way how the feature extraction is going to be done. It's very important for you, right? Listen carefully, don't make noise, right? Okay. Let me take you thus. You know very well about the sentiment analysis. Here is an example. I took the Twitter data. Here is one sample tweet in front of you. I am happy because I am learning NLP. What is the sentiment this tweet is having, consisting of? Happiness. So it's a positive sentiment. So sentiment analysis is given a tweet on Twitter data, given a text or tweet. It has to identify whether the tweet is consisting of a positive sentiment or negative sentiment. So simple, this is the task of sentiment analysis. This I am going to do using the concept of logistic regression. Yesterday Neil sir started with ML algorithms are dinosaurs. No, still these are useful. Because these are basics, foundations are there. More beautiful way, in an efficient way we can use that. This is the reason why intentional I am going to show you. Even you are coming to the concept of text processing with NLP, I wanted to show you this sentiment analysis with the very basic machine learning algorithm logistic regression. So that you can understand what is the power of this one, right? Okay. You know very well about this logistic regression model. Your logistic regression model is going to be trained against the training data X, which has been already be labeled with Y. During this training process, it is going to capture the meaningful relationship between all the tweets in the training data set. Once these features were captured, then it will do the predictions for the same training data and compare these prediction results Y hat with the original labels Y, and we will find out the cost functions. And this cost function, in order to optimize this cost function or the loss function, parameters will be updated. This is the complete training process. Once the perfect training is done and the model is ready, a sample random tweet like I am happy because I am learning NLP is given to this LR model, logistic regression model. It is going to find out the sentiment of that, whether it is a positive or negative. Here the positive are labeled as 1 and the negatives are labeled as 0. So the first thing is architecture I had shown you. Now the thing is vocabulary creation and feature extraction. Mine is all these tweets, Twitter samples, tweets, which is the text data. From this text data, I need to feed this text data to the logistic regression model. What it is taking is numeric. From this text, I need to extract the features. This starts with the vocabulary creation. So the next topic is vocabulary creation and the feature extraction. These are the pre-processing techniques, whatever we had discussed. For this Twitter sample data of this case study, these are the pre-processing techniques that we are going to apply. Okay, let's see one by one. Stop words. If this is the tweet like this and a list of the stop words and the punctuations were identified, and whatever the stop words are there in my tweet will be captured and those will be removed. Once these are removed, this will be the process. The tweet I am going to take. This is one level of pre-processing called stop word removal. Then this input will be given and process recognize the punctuation marks. So now that input is going to, what are the punctuation marks? You can see exclamatory mark is there in my punctuation list, that is there in my document. So it is going to be removed. So I am left over with, this is the processed tweet after removal of punctuation marks. Are you observing how I am coming one by one? The first time I removed stop words, then in the next step I removed punctuation marks, then I will go for the next. What is the next? URLs are there in my tweets. Do I need of the URLs to find out what is the sentiment it is having? Not required. Handles and URLs are to be removed. That's what I am doing now. At the rate, sir. The sentence starts with the at the rate. Handles are not required and the HTTP URLs are not required. That also to be removed. So I am going to get over with tuning great AI model. From this complete, I am getting this process. Tweet. Tokenization not yet done. Now from this, what I am doing? Tuning is the word is there. What I supposed to do? Stemming and lemmatization. Once I done with that, I left over with, you know the meaning of the stemming and lemmatization. I am not repeating this one again. And lower casing. So my tweet has been changed to 10 great AI model. Did you observe? Earlier great was in capital letters, AI was in capital, all were lower case, tuning was converted into 10, right? What is the next step? Once this pre-processing is done, I did the tokenization. Now I got a list of processed tokens. This is my original tweet where I pre-processing started, and these are the processed tweet, which is a list of processed tokens. After removing all punctuation, stop words, converting lower cases, stemming and lemmatization is done. URLs were handled.
That happens in time.
Now this is important, listen carefully. Okay, pre-processing or text processing will do the processing and tokenization will create a list. But the main concept is vocabulary creation. I am going to show you with a sample, right? Look at here. These are the number of tweets that you are having. Tweet 1, tweet 2 and so on, tweet m. From these tweets, what you are having is called the corpus. First is I am happy because I am learning NLP, I hated the movie, likewise. All these are called corpus. From corpus, vocabulary, which is a list of unique words to be created. List of unique words, right? How to do this one is, main thing is, in order to create this vocabulary, the first thing is required. Yeah. Now here is the concept of word to number. What is the need of this word to number? Your tweets, all these things is called text. But your network model, logistic regression model, input for the logistic regression model is number, numeric. How to bridge this gap? Text to numeric, right? There are different methods are there for doing this task. It's already been discussed in the morning session also briefly. One-hot encoding, word embedding, which consisting of word to vec and TF IDF. I am going to use in this model TF, term frequency, for converting my text into numeric features. Let's see the feature extraction. So I am happy because I am learning is the sample tweet. Like with all these tweets, first a vocabulary will get created, a list of words, you can see, and so on. It can be 2000 words or 5000 words, whatever, depends on your sample size. A list of unique words will get created, and you can, if you observe, these are not at processor, I and am are still there. Okay, once done the processing, those will not be there, right? Now, this each tweet across this vocabulary will be converted into the numeric. If you follow the one-hot encoded notation, what are the words in your sample tweet? For those words in the vocabulary represent, give the notation is 1, presents if that word is presented, give 1, otherwise assign 0. So that for the sample tweet of 8 or 9 words in my example, I am getting a vector, one hard encoded vector of length, vocabulary size, 2000 or 5000 words. Do I need such a lengthy numeric vector for representing my 8-word sentence or the tweet? Not required. Getting my point? My tweet is of 8 characters only. I am happy because I am learning NLP. Sorry, 8 words only, 8 or 10 words only maximum. If we converted into this one hard encoded representation across the entire vocabulary of like this and so on 2000 words, I would come up with 2000 element vector of ones and zeros. Those are only across all 2000, only 8 positions are ones, rest of all are zeros. This is what called the sparsity problem. This is to be avoided. So, one hard encoding is not recommendable. This is sparsity representation because it consumes large training time and the production time. Okay. So, what I am taking is, as I said, term frequency. That is what I am going to take. It's a corpus in the sentence will be captured by the concept of entity, named entity recognition. All the named entities, whether the person or an object, an articulate or an organization, it's a geographical location, these will be captured. This is another way of pre-processing. Okay? These are all the different pre-processing techniques. I am of 4 sentences you can see here. I am happy because I am learning NLP. Is it positive or negative? Okay. The second tweet, I am happy. I am sad, I am not learning NLP. I am not sad. So, in my corpus, I took 2 positive samples and 2 negative samples. Am I clear? Right. With this corpus, this is a sample I am going to explain. With this corpus, the vocabulary which has been created, not yet processed. I am telling, not yet processed. So, these are the words in my vocabulary. What are the number of words? 1, 2, 8 words. 8 words in my vocabulary. Did you observe? Unique words. I appeared for many times, but I took for one time only. Right? From this corpus, sample corpus of 4 tweets, among 2 are positive, 2 are negative, this is the vocabulary has been created. Now, let us see how the frequencies are going to be calculated. First of all, find out the positive and negative frequencies. How to find out this one is, among those 4 tweets in the corpus, I took these are the positive tweets and these are the negative tweets. It's very clear, right? Now, with this positive tweets across the vocabulary, find out these words appeared how many times in your positive tweets. Okay? Each word, say suppose happy is the word in the vocabulary which occurred 2 times in my positive tweets. So, positive frequency count is 2. Please observe with what I wrote within the bracket is 1. This is the class. 1 is positive class, 0 is the negative class. The word in the vocabulary of positive class appeared how many times? 2. Similarly, the rest of words also. I had appeared for 3 times, am had appeared for 3 times, sad and not for 0 times. Why? Because? Correct. Those are the words in tokens in the vocabulary, but those are not appeared in the positive tweets. So, for what I am doing is, for each word in the vocabulary, calculating the number of times that word had occurred in positive tweets. The same thing I am going to do across negative, that is it. Negative tweets, vocabulary, frequencies. You can see this. The word happy and because, what is the frequency count in the negative class? Because those are not appearing, those are the positive words, does not appear in the negative tweets. Okay. In the next step, I am going to combine these two. Vocabulary words with positive frequencies and negative frequencies. So, this is called the frequency table, which is a dictionary mapping word and class to frequency. The meaning is, Happy is the word which with the class which occurred to with the positive sentences, positive classification has appeared for 2 times. Happy is the word which appeared 0 times in the negative tweets with the class 0. Okay. Your feature map will be, the feature vector will be a dictionary whose key is a tuple with word and class, and its value will be number of times it has occurred, frequency, right? That's what is. This is what. Input feature of the tweet M is a 3-element vector. The first is the bias term that I am going to taking it as the token. Second term is the sum of positive frequencies. This is nothing but that word has occurred with the positive, how many times it has occurred in the positive tweets. Summing of all the positive frequencies of that. And next, third term is, it's a sum of negative frequencies. The same word, how many times it has occurred in the negative tweets. So, for each tweet, whatever the length and number of words, it is going to be featured as a 3-element vector. Am I clear? And the earlier case of one-hot encoding, what had happened? 8-word tweet has been converted into vocabulary size, let it be 2000 element vector of 8 ones and rest of all are zeros. Now, did you observe what is the difference between these two? This is what called one way of term frequency way of embedding and converting the word into the numeric. How beautifully we are doing that? Whatever the length of the tweet is, whether it is 2 or 5 or 10 or 20, it will be represented, featured as 3-element vector. Clear? So, what are those 3 elements are? The first is the bias, second is the positive frequency sum, third is the negative frequency term. Good. Thus, I am sad I am not learning NLP is the sample tweet. Across the vocabulary, the positive frequencies are, what are the positive frequencies? Can you tell me what is the value for this tweet? This value I need. Anybody? This is the sample tweet. I am sad, I am not learning NLP. For this tweet, calculate the positive frequencies in the vocabulary. Exactly, correct. So, this value is 8. Can you guess the value for the next one? Somebody is saying, right. That's what. Just whatever these highlighted. These are the words that has been appeared. I am sad, I am not learning NLP. In the negative frequencies now you have to see. These are the corresponding frequencies. 3 plus 3 plus 1 plus 1 plus 2 plus 1, it is equivalent to 11. I think you said 9. Okay, right. You understood? So, for the sample, so what exactly the overview of feature extraction is? A tweet like this, I am sad, I am not learning NLP, will be converted into the extracted feature 1, 8, 11, 3-element vector. This is the overview you can see here, but in between processing would be there. So, among these 3 elements is, first is the bias term, second is the sum of positive frequencies, and third is the sum of negative frequencies of this processed tokens of the tweet. This is how the features will be extracted from each tweet. Okay. From the corpus of 4 tweets, I would get 4 list of pre-processed tweets from these feature vectors got generated. This I had shown for 4 tweets. If you have the m tweets, it would be for m. So, what is the size of this your feature vector? Total size of your feature vector? M by 3. M tweets, each tweet of length 3. M by 3. Clear? Just back to sir, collab code. NLP sentiment. Scroll up. So, here we are using Twitter samples data set, which is consisting of the JSON file. Just a brief about the data set. Here the data is available in 2 formats, 2 partitions, positive samples, positive tweets and negative tweets separately been available. Okay. These are the JSON files. You can download it from the nltk.download Twitter underscore samples. You can download it from that. Come down. So, these are the JSON files. You can see that calling the fields method, it can give you what are the contents, negative tweets and positive tweets. Both being separate files or JSON files are existing. From that positive tweet text to be extracted, that you can do with the string, calling the string method. Come down. Yes, you can see here. All positive tweets has been extracted from the Twitter samples dot strings of positive tweets.json file. Are you clear? From the JSON file, I am extracting all the positive tweets by calling the strings method and passing that particular JSON file. So, I would come up with all the positive tweets in one file and negative tweets in another file. My positive tweets are there, negative tweets are there, there is no labels. I have to assign. For training my logistic regression model, I need to feed both the input along with the output. I know this is positive and negative, but there is no labels that I have to be created. Fine. If you have a look on positive tweets, this is how these are going to be appear. Just come down, sir. You can see this URLs are also there. One second. Just to show one URL. Yes, HTTP. Yes. You can see the URLs how they are appearing. http:// something and handles are there at the rate. Hashtags are also there. Similarly, I have the RT tags also. And can you show this one? This HTTPS. This one. Yeah. Here is another HTTPS. I am having the URLs with HTTP and also HTTPS. Is it clear? Just have a look on how the data was there. Tweets are there. Then you can decide how to process. Right. Come down. Downs. Just right side you can scroll down. Come down. Yes. So, totally how many tweets are there in my is 5000. My data set size is positive samples are 5000 and negative samples are 5000. A total of 10,000 samples are there. Come down, sir. Down. It's only 5 samples. It's showing the first 5 positive samples. Already we had shown, no problem. You can come down. Down. Yes. Processing. Come down. So, these are the different processings that we had discussed. We are doing that. Come down. I can show you how these were done stage by stage with one sample tweet. I took the sample tweet, all positive samples of index position 2277. Among my 5000 samples, I took one random sample tweet and trying to show you the what is the effect of the each processing step. Come down. Down. Yes, down. Some repetition is there. Regular expressions were used in order to process that HTTP URLs. We are replacing, substituting these URLs with spaces. Within each tweet, for that I am using regular expression substitution method. RE dot substitution is a regular expression, and this is the pattern match. Whether HTTP yes question mark, if you use yes is optional, if you use yes question mark, it will cover either HTTPs or HTTP yes. We have both this, so that's the reason why I use. These two are the pattern matches, double slashes. This is directly was specified with the considering the raw strings, or else you have to specify with the backspaces. Okay, right. You can see how it was converted. My beautiful sunflower on a text. This is the original tweet which is having move on, right. Which is consisting of the URL that has been removed by using the regular expressions. Come down. Next. You can see how the different ways I handled these things. Come down, sir. Down. Directly you can go this. One second. Scroll up. This is already we had shown, no problem. Come down. Processing against stop words. Directly you go to the pre-process method. For the same tweeted sample, I had shown all the ways of pre-processing step by step, and directly I am taking you to the method called pre-processing, stemming, lemmatization, all these things. Pre-process, yes, process tweet, come down. Show this code set, yes. So, in order to do the processing, whatever is required, whatever I had shown in the pre-processing, text processing method, all those libraries and modules were downloaded here and imported here. Stop words, porter strummer, tweet tokenizer, all those things come down. And this is how this function was defined. Have a look on this function. I am going to give a brief. Process tweet is the method which is going to process the tweets. Tweet is the input that is going to be processed. So, created the porter stemmer, instance of the porter stemmer. Yes, okay. Then the stop words have been downloaded. You can see how each tweet was processed. Using the regular expressions, I processed the tweet against the tweets which have been started with the dollar symbol, and the tweets tagged with RT, and the tweets started with HTTPs, and the hashtags were also removed. And then we did the tokenization on the processed tweet. Once the tokenization is done, you will get the list of tokens of each tweet which have been processed. Come down. You can show the output. Along with the stemming and lemmatization process. Show the output. Come down. Yeah. The same is the sample tweet which I have taken. Once the processing is done, you can see here. This is the original tweet. And the output processed tweet also you can see. My beautiful sunflowers, that tweet was converted into the list of tokens. Come down. Now we are focusing on creating the frequencies. For creating the frequencies, what we did is all positive tweets are in separate and all negative tweets are in separate. These are merged together. so that I come up with all the 10,000 samples, my tweets. Okay, come down. Yeah, as I said, I have the input, all positive and negative tweets, but where is the labels output? I don't have. Am I clear? I know these are the positive and negative with the file name, but I don't have the labels. In order to train my logistic regression model, I need the labels as well, right? So for that I am creating NP numpy arrays with ones and zeros. See, I merged positive followed by the negative. So first 5,000 samples are positive tweets and the remaining 5,000 samples are negative tweets. So I need to create the numpy arrays with first 5,000 samples are ones and second next set of samples are zeros. That is what we did it here, ones and zeros, so that just a little bit more. Yes, if you can see 10,000 element vector has been created with the first 5,000 samples as 1 and the next are zeros. Come down. Next step is building frequencies. What I had illustrated in the slide, same thing is here. What is the input for, one second, what is the input for frequencies? Input, yes, tweets and labels, ones and zeros, right? Okay. So frequency is a 3-element vector. Token followed by the class, it's a tuple, it's a key, it's a dictionary. It has to return a dictionary with the key is a tuple with the token and the class, whether it is a positive class or a negative class, and its value would be how many times that combination has occurred, right? This is the output of this method. So output is a dictionary. This is the logic of processing and getting the frequencies. By looking at the already illustrated in the slide itself, you can, looking at the code, you can understand easily. So what is the, you can see the output. Just hold on one. Yeah. Follow Friday is the key token of class 1. The meaning is positivity, positive class. This token of positive class occurred how many times? 25. The same word of negative frequency, negative samples occurred for how many times, that also is also going to get generated. That you can see in the latter cases of the same list. Come down. That I can show in with another word top. You can see here. Positive frequency of the word top is 32 and negative frequency of the word top is 6. The meaning, the token top has occurred 32 times in the positive tweets and 6 times only in the negative tweets. Is it clear how features was extracted? So this is the function which will generate the features for the tweets. Now I already defined the function, I had illustrated how it will do, right? Now what I supposed to do? My training data is to be passed to this method so that it will generate the feature vectors, right? Come down. Here is the sample is also given, a list of words is given, how it has been generated, the same method also shown here. Show the output of this code cell. You can see how it is going to get. These are the new words. Okay. You can see emoticons are also used. This symbol, come down. Yeah. This emoticon, sad emoticon had occurred only one time in positive classes, tweets, and 3 times in negative. Is it meaningful? It's a sad icon. It occurred 3 times in the negative tweets and only 1 time in the positive tweets. It's a meaningful, sensible, right? Okay. Song has occurred 22 times in positive and 27 times in negative. This is how it is going to, that function is going to give the output. Come down. Now the data preparation is so easy. I had all the samples in tweets, 10,000 samples. So I wanted to do making it the ratio of training and test set splitting 80-20, right? 80-20 means first 6000 samples for training, rest of 4000 for testing. That's what I did it. Test positive samples, training positive samples, test negative samples, train negative samples with the slicing of last 4000 and first 4000, sorry, till the first 6000 samples. So, positive and negative training samples for training and testing were created. Come down. Down. Okay. Then labels also to be created. Already I had created, the same way used to be splitted. First 6000 is for training Y samples and remaining, sorry, first 6000 for remaining 4000 for testing Y labels. Down. Okay, so that you got the training shape is 8000 by 1 and the test shape is 2000 by 1 across the 10,000 samples. Done. Okay, 1 minute, scroll up, scroll little bit, yes. Now build frequencies, you can see here, I told you, we defined the function build frequencies, we have seen with the sample. Now what I said, training, it's 3-4 minutes is sufficient to wind up. Already we had illustrated in the slide, right? Yes, just copy. Okay, training examples and train labels have been passed to the build frequencies method, so that your features for the original data will be obtained. These features you are going to feed it as an input to the logistic regression. That's where we are moving on. Come down. These are the features, how they have been generated. Extracting features by passing this function was defined, we already illustrated. Move on. Move on, sir, already explanation is over. Right. Just a little bit up. Up. Little bit up. Yes, just wait. You can see here how the features were extracted. One particular sample of the training data set. I told you it is a 3-element vector, right? First is the bias term, 1. Second is the positive frequencies, 3 into 10 to the power of. Third is the negative frequency, 6 into. Got it? How the features were extracted? Good. Come down. Similarly, the labels. Okay, 1 second. Here I tried to find out, try to extract the feature which doesn't available. So I got the positive frequency count 0 and negative frequency count 0. I just verified, cross verified. So you have to train the model. This is a regular process. Come down, sir. It's easy thing. So my training data is ready, test data is ready. Yes. Now we fitted the logistic regression model with the training input samples, training labels, and done the predictions. Come down. And evaluated the model with the confusion matrix and accuracy was calculated. My test accuracy I got is, what is the test accuracy I got? 99%. Can you imagine? 1 second. Can you imagine? I told you in the beginning, we are processing, we are doing the NLP task, we are processing the text, but I am using a basic ML algorithm, logistic regression. Did I got the very good results? Absolutely. All the time you need to start from the beginning. Sometimes for certain applications, basic ML algorithm will themselves will best fit the models. This is what I tried to prove it here. I got the text accuracy is 99 and I shown the training accuracy only with the test data, training data set I left over with only 77 or 80 samples or misclassifications. Okay? Yes. At last I tried to do with my own tweeting. Okay? Completely new, which is not there in the either trained data set or test data set. You can see here This is the last one. Okay, come down, sir. Can you come? Okay, come down. Yes. This is already available one. It's been identified as a negative tweet. I just cross verified with the win. This is the sample tweet which is been indexed with 5020. Can you show this output of this code cell? Last. Go to the last one. Last. Yes. What is this? 0 represents negative. Did I get the same result? In the original itself is the negative tweet. Okay, that 0 is representing the class in the original itself. That is the negative tweet. Even my model prediction is also little bit up. Little bit up. I just hold on. Just down output. Negative sentiment. Okay. I tried with the 2 more my own sentiments, tweets, little bit up. Tweet code cell. Yes. This is my ridiculous. I am very happy because I am learning. I got the accurate results, positive sentiments and negative sentiments. For the first one, ridiculous, I got the negative sentiment. For the second, I am happy because I am learning NLP. I got the positive sentiment. Okay. This is all about NLP application, tasks and sentiment analysis. Any doubts? Okay. Thank you very much.